Hey everyone, welcome back to another programming speedrun challenge. Today we're going to be speedrunning the very first assignment for my C programming and Unix class. I'm taking this about 2 years late due to scheduling conflicts. So I know pretty much all the material already, hence why we're speedrunning it. So I haven't looked at this assignment at all. And so yeah, we're basically just going to pop into Vim here. I just made an empty file, easy project. The make file doesn't have anything. It just has to be there, so Vim will detect this as the root directory for our C project. But luckily, we don't need to make file or C compile commands or anything, right? Because this is a basic C programming class, so pretty much everything's going to be in one file. And we have no dependencies. That'll simplify just a lot of stuff. Yeah, so we're going to hop in here and get started. Actually, I'm going to move this over here. Yeah. All right. Start the timer. Okay, let me rename this. Funny name. Oops, wrong language. Today is 1/23/24. It's 2024. Wow, I'm old. No global variable is okay. Command line. Okay. This isn't too bad. You just convert each string one at a time. Okay, nice. This is pretty doable. Shit, I forgot. It's I don't know if that's a convention. Whatever. Yeah, I haven't written C in a couple years, so it'll be a little slow. %s/n. This is going to be... I'm just curious if this seg faults, and we're going to have to include comments. sysgdio.h. This compiles. And change that. And then we're going to cd c. Let's just get that set up. Okay, yeah, so this does work. If we run this with more stuff, I'm actually going to set this up to run A1. Okay, cool. Yeah, so we have this working. We have our strings here. I wonder if he wants us to use the C functions or if we can write our own. Okay, it looks like he has the math here, so I'm going to assume he wants us to do the math manually. So we'll just make a helper function here, int parse hex. Yeah, because then once we need to, basically we have to print the hex and the decimal, but we can do this with printf. We just need to go from the string back to the int. Actually, this should be const here. We want our good constnist. Just call this hex. And so for this we need to go backwards, right? So we'll get the len. I think that's an stdio. There's probably string.h or something, whatever, as long as it compiles. So we have the length. Now we're going to go backwards. I equals len. Len -1 will be the last character. Len is where the null terminator is. I is greater than or equal to 0, and this is signed, right? So it has to go negative for us to break here, which is fine. I minus. And I'm sloppy, so I'm going to just double check that this is doing what I want. D/n, and I just want to print I. Make sure I'm iterating correctly. I think this is string.h. What are you crying about? Oh, semicolon. I need to call this for each one. Sub I. Right, and we'll just set up this num variable so that later we can return this, and we need to declare this function. It's nice having main at the top, even though we could do it the other way around. And we'll just, so it's funny, it gives a warning for not returning. 6, 5, 4, 3, 2, 1, 0, 1, 2, yeah. Wait, why is this 6? That's interesting. That's, oh, because we're passing in, this needs to start at 1 because we don't want to, we don't want to try and parse the name of the program as a string. That wouldn't be too good. Okay. Nice, so this loop is working. What's next? Okay, so we're going backwards. We're basically going to do result plus equals. He says no. Okay, we can do it locally. It's fine. So because this is a hex digit, right? There's kind of two cases to this. When the digits 0 to 9, because these are like contiguous in ASCII, but then also A to F is a different range that we have to check for. So I'll just say int digit equals. Yeah, we can do a ternary here. Actually, no, we should parse this properly. We'll do error handling later. That's fine. So we're going to say the digit is hex sub I. I almost forgot how to do ternary. So x sub I, if that's, we need to find out which is bigger. I don't remember the Python. Oh yeah. So ord of 0, ord of A. Right, so these numbers are going to be the same in our C program. This is just ASCII. And so A is bigger, right? So here we're going to say if this is greater than A, then we know it's A to F. So we're going to do hex sub I. The compiler will optimize this. We shouldn't have to worry too much. Minus A plus 10. Otherwise, hex sub I minus 0, right? Because that's 0. We'll get our formatting here, and now we can just add. Actually, we can do some nicer error handling here. We'll say if it's whoops, this needs greater than equal to A, and we'll just store it here so we don't have to type this out. So if it's greater than or equal to A and C is less than or equal to F, then and then else, this is basically error. So otherwise, it should be greater than, whoops, this isn't Rust, greater than or equal to 0, and it's less than or equal to 9, then it's this digit, minus A. I think it's, oh, I hope he said it's all uppercase, right? Yeah, okay. That would be another thing we'd probably want to handle, but oh well. And then this guy is going to be minus 0, and then it starts at 0, so we don't need to this plus 10 here. And we'll just print. Bad digit. We'll just print a single char, which is going to be C. Okay, then we don't need this helper code anymore. We add, it's going to be, so starting from the left side, so every time we increase, we need 1, right? So basically this, so right now we're just kind of summing the digits. We don't want to do that though. We basically want to multiply this and then make the base bigger. So I'll just some debugging code here, right? So this is going to be result %d base digit. Okay, and then it's going to be C. Okay, and we don't need Python anymore. Yeah, who likes Python? And we want some nice new lines so we can actually read this. So this is hex, right? So obviously this is going to be 16. And let's just zoom in here so we can see what's going on. So he's testing with A1. I think we're doing the same, yeah. So A1 should print 161 in decimal. And let's just do print a new line after. Result 176, is that right? So we're starting here. Result is 1, that's good, base is 16. Then we add 16 times A, which is 160. 10, 8, 10, yeah. And so we multiply, we scale up the base. No, we need to do this before we add. Now that should be right. And now the result. What? Okay, I think our digit's wrong. This is good because at least for A1 we're testing both like the above 10 and the less than 10. So digits 1, digits 10, result 1, result 26. What do you mean result 26, bro? This base. This is something that happens after. We don't want to do that. Base 1, base 16. Oh, no, I'm a dummy. So we want to add the base times the digit, right? Because basically each digit is multiplied by 10 to the 0, 10 to the 1, 10 to the 2, but we only multiply once. We could accomplish this with clever bit shifting. In my mind, I was writing this as if it's base 10 and we have to multiply, because 10 is kind of awkward for binary. Here we could literally just map each thing directly into the number, but oh well. Yeah, this should do 161. Yep. Okay, so the parsing works. That's good. And we're returning our result, right? So this function should work as is, and we'll just print out in so we're nice. We'll print out the string as well, so they can see which one. Actually, we can test this here. And here we should just we should exit with an invalid code. See what header is it in? strlib. Okay. Okay, that works. So if we put like what's a non-hex? Yep. So we get a bad digit S in A1, and we don't want the new line here. We want it at the actual end. The hell? Oh, not home row. Okay. Yeah. Okay, so we don't have to worry about error handling, right? Because we terminate the program. This will always give you a valid parsed result. Otherwise, the program won't run. And now we have our num. So now we can just printf this bad boy. If I could spell. Printf. All right. So what's the format he wants? So he wants the hex, which we can just print the string we get in, space hex equals, and then this is going to be the decimal /n, and then the arguments are going to be our at I, and then the D is going to be num, right? If I fix this, we should get 411, 100F, CAB, Oh no, is he going to tell us which functions to use? Okay, that's fine. Case insensitive, that's a little bit annoying. Okay. Yeah, I totally misread this. I thought we could just skip ahead. Yeah, okay. Nice. Okay, so really all we need is, I'm going to use a bool. I think it's std bool. Nice. Because yeah, this should just be like type def to int underscore bool, whatever. Yeah, basically it's just, you know, it doesn't actually change the way it's compiled because under the hood it's still an int, but it lets us, to the programmer, we're like, oh, this is a bool, it's only going to return true or false instead of any random int value. Okay, so is hex. And so this is another thing we can do in naming, right? Where parse hex, we're going to assume it's hex when we're parsing it, and we'll exit the program nastily for this case. These are basically, the precondition is this is hex, right? Whereas this is just a string. And these have the same type, so to the compiler, these functions are sort of the same. But actually to us, this is a string, so it could be anything, and this is hex, so it should only be a hex string. So basically at the bottom, we're going to return true. Equals strlen of s 0. We don't have to go backwards this time because we just care if it's all valid. So if c is less than, what's the easiest way to do this? So if c is not in the range of, so if it's greater than or equals to 0 and less than or equal to 9. Yeah, so basically the way I like to do this, think about this, is so if we're not in 9 and we're not in A to F and we're not in lower A to F, right? This is basically our condition now, except this is that, right? Where if we're not in any of these ranges, then it's definitely invalid, right? Because otherwise we can parse this, we know what to do if it's in this range, right? We just do our math, and we can do it for this, and we can do it for this. But if it's not any of them, then it's definitely out of range. So we'll just kind of stick that in code here. The syntax gets a little wonky. I'll just use some Vim stuff to make this a little faster, and make this a little wider, right? Yeah, we'll format this, okay. Yeah, so if it's not, so basically this expression is going to be true if it's in this range. This expression is going to be true if it's in the A to F range, and then we're going to have this be lower A to F. Ideally we should write some tests for this too, but who cares? This is like some random school assignment, because I don't actually know, like this function should be fine, but you know, it's very easy to write bugs. So that's not the case. Then we want to just early return false, because we know this is in the string. I think he wants it 1 and 0. Return 1 if it's hex. Okay, yeah, so basically yeah, so it returns true if it's a valid hex string. My spelling sucks, hopefully that's right. And so now, instead of parsing first, we're going to say if is hex, and then we're going to parse and print. Whereas we should keep this. And we need to declare this up here because C is awesome. Why are you crying? printf. Oh, we gotta close that. Okay. Yeah, so it is hex. We parse it and print it. If it's not, we're just gonna copy his thing. It'd be nice to say which character is, like what we did before. But I think that's a slightly better way to do it, to tell you which thing's wrong, but whatever. This string. And then we need to fix this so that this works if it's in the lowercase range. Then we're going to subtract lower a and add 10. And I mean, ideally we should, I kind of want to write test just because I don't know if this is actually right. It gives us the right answer. I guess we could say this is our test here to make sure it matches with what he wants here. And it does. Let's just throw it. Okay, that's good. Yeah, so at least it'll print the rest, right? And if, let's say, the first one's messed up, it'll still parse the other. Wait. Oh, we need a new line here. There we go. Cool. Yeah, so this should work basically no matter what. Get rid of this. They're all valid. Oh. There we go. Yeah. So I'm gonna call that done. I'll write some more comments here just to clean this up a little bit, and just make sure, reread this, make sure I didn't miss anything dumb, and as far as like formatting or whatever. But yeah, I'll stick with you for the comments here, but that's about it. I wonder what my time is. Hex string. This one has a comment. And we'll just kind of comment our main to say what it does. Takes hex Oh, the thing is, I'm printing this kind of a cheese. I'm printing the string here. He probably wants this to be in hex, which I forgot how to do in C. Is it uppercase X? Okay, no, it's just worried about the types. Right, so now we can use the same num, even though we're actually printing it in hex. And yep, that still works. I forgot how to, okay. Representation, I think that's how you spell it. Yeah, let's hope for the best. Parses, yep, case insensitive. Case insensitive. Cool, let me just reread this. So yeah, we titled it correctly. Name, due date is 28, I think. I guess technically I did use, what was this website? Nah, this kind of garbage. We don't have to exit anyway. I knew it, I just had to look up the API, so no need to put that in. Yep, we know global variables. This is all local comparisons in math. Take one or more strings. Yep, non-negative. This should be, let me think. Yeah, these should be unsigned ints, right? Because we're basically throwing away that final bit. That if set will flip this to a negative number when really it's supposed to be unsigned. So anywhere that's a return type, that's not going to be unsigned. Len, I actually len. Oh, it's a size t. Oh, so actually it is supposed to be unsigned. Okay. our loop condition, whatever. But yeah, basically this result should be unsigned and the return type should be unsigned. Oops. And we gotta change this here, right? And so we're adding, yeah, so we could actually test this if we try to parse an int f234. This should be, are we printing? Okay, this has to be a U actually. Yeah, and so this is supposed to be unsigned, non-negative. Yeah, this is pretty subtle. I wonder how many people kind of skip over this. I almost skipped over it too if I didn't pay enough attention here. Yep, one thing only. You could argue like, okay, this should be like parse digit and whatever, but I don't completely agree with this philosophy, so we'll just stick with it. Yeah, we have our function determine its text. We want to parse it. We use that in main. Base 16, yeah, we basically do this math. It's when he puts the parentheses here. Yes. Oh, okay, he does type it here. That's good. Test it thoroughly. Yeah, we should write tests in an ideal world. It kind of gives me the ick that we don't have tests, but I don't care enough to do that, so oh well. Just make sure these ranges are correct. Yeah, I wonder if they have like some automated test case thing they do, or if the TA just kind of runs it. Cool. But yeah, if you made it to the end, thanks for sticking around. This was a fun little assignment here. This is the first one, so expect the next ones to get more complicated, but I'm going to keep speedrunning this to see how quick we can get it done. Hopefully my C chops will come back a little bit. I won't have to Google things, and I can just kind of blast through this stuff. So yeah, thanks again for stopping by. Hope you guys enjoyed.